Assalamu alaikum, I am Asayr Shamri. Today we will talk about our project car parking sensor using 3-bit binary asynchronous counters. These are the contents counters and asynchronous counters, synchronous counters, application of counters, 3-bit asynchronous counters, counter design, parking sensor solution, and the conclusion. The counters, sequential devices to count events and process. Asynchronous counters, also called ripple counter, clock is fed to first flip-flop, preceding stage out is fed to next stage clock input, slower compare to synchronous counters. The synchronous counter, same clock source to drive all flip-flops, faster as compared to asynchronous counters. Application of counters, the first one is frequency measurement, digital clock frequency divider, time measurement A to D.
This is Dal, and I will talk about 3-bit binary asynchronous counter. Here I will talk about 3-bit binary asynchronous counter. We have three different states. First one, initial state, all flip-flops are initially reset to 0, which means Q equals 0. The second state, it's first clock pulse. The first clock pulse triggers the first flip-flop FF0 to toggle it to state 1, which means Q equal 1. The second state is second clock pulse. The second clock pulse arrive at the first flip-flop, but since its Q output is already 1, it doesn't change. The receding edge of the clock triggers the second flip-flop FF1 based on its J and K inputs. And here J equal Q0 refers if Q output equal 1 and K equal not 0, which means Q is 0. As J is dominate over K, if F1 output becomes 1. Subsequent clock pulses, the process repeats for subsequent clock pulses. Each time a flip-flop's Q outputs change, it triggers the next flip-flop in the chain to change its state. Counter sequence, the counter progress through a sequence of binary numbers from 0 to 7, and here a reset signal can be provided to all the flip-flops simultaneously to bring the counter back to its initial state. And here I will talk about counter and design. In a synchronous counter, a clock pulse drives FF0, output of FF0 drives FF1, which then drives the FF2 flip-flop. All J and K inputs are connected to logic 1. Therefore, each flip-flop will toggle with a negative transition at its clock input. The 3-bit mode 8 asynchronous counter consists of 3JK flip-flops overall. Propagation delay time is the sum of individual delays. Initially, all flip-flops are reset to produce 0. The output condition is Q2, Q1, Q0 equals 0, 0, 0. When the first clock pulse is applied, the FF0 changes state on its negative edge. Therefore, Q2 and Q1, Q0 equal 0, 0, 1 on the negative edge of second clock pulse flip-flop FF0 toggles. It outputs change from 0 to 1. This begin negative change, and F1 change state. Therefore, Q2, Q1, Q0 equal 0, 1, 0. Similarly, the output of flip-flop F1 changes only when there is negative transition at its input when the fourth clock pulse is applied. And here is the counter design. We have designed a 3-bit binary asynchronous counter in a logic works using JK flip-flops and binary switch, as well as we have used 7447 BCD decoder IC to show the counting on the 7-segment display as well. Total 3 JK flip-flops are used. The JK inputs of all flip-flops are giving high value of 1 input. The first JK flip-flop's clock is giving an input signal. The output of first JK flip-flop is fed to the clock of second flip-flop, and the same is done with the output of the second to the clock of the third flip-flop. The output of each flip-flop is also fed to the 7447 decoder, so that we can display the number on the 7-segment display as well. And here the circuit we have done is shown below.
Hi, my name is Taif, and now I will talk about the parking sensor simulation. We have used 3-bit asynchronous counter to show the working of parking sensor usually present on the front and rear end of the car. Main operation closes in IR systems, in IR sensor and buzzers, which start to sound as soon as the distance between a car and obstacles is too close. Here we implement the same concept using 3-bit counter and 3 different LED lights. We made an up counter, and as the counter is increasing, the LED light go from green to red to yellow to show how close his car is from the obstacles. Green means that we are in the safe distance. Yellow means that now distance between car and object is decreasing, and red means that we are very close to obstacles now and dangerous, including imminent. The implementation, however simple it might be, successfully implemented the working of paper parking sensor. And here the application is based on the logic to work. At the end of our project, the project successfully demonstrated the construct and operation of the parking sensor using asynchronous counter. We showcased async behavior through a simulation and variable its output sequence against the expression value. Additionally, we integrate the counter with a 744 BCD dictator to visualize the counter number in 7-segment display, providing tangle demonstration of the functionality.